Well, I'll tell you what, there may be a few other folks joining us once we get going here, but let's go ahead and kick it off. I'll start by just welcoming everybody to our professional development this evening. We're really excited to teach and share some more information with you about the Lieutenant Governor's Computing Challenge. This is a statewide challenge that was launched for Jen, is this the third year or the fourth year of this challenge? This was the fourth year. Okay, great. So this was this currently is the fourth year of the Lieutenant Governor's Computing Challenge, and we launched back in December. It closes at the end of April, so we are coming down the final home stretch here for this computing challenge. So the focus of tonight's professional development is both to share some more information about the computing challenge, also about computer science more broadly in Connecticut, just so you can kind of see where you and your district are sort of fall in the range of what's going on with computer science in Connecticut. And also to talk you through how to submit different ideas to the challenge. And finally, show you some different entry points. This is our second professional development in this series here. We went over a couple of different entry points in the first one, and we'll go over a couple of new ones in tonight's professional development. So just to kick things off, we know kind of what and where you guys teach, which is great. We also are interested in whether or not, have you guys heard of the Lieutenant Governor's Computing Challenge before this year? You can let us know in the chat. We'll kind of use the chat to communicate this evening. But before this year, had you heard of the Lieutenant Governor's Computing Challenge? Yes or no? Let us know in the chat. All right, this is Jordan's first time hearing about it. Excellent. You're in good company. Most of the folks we talked to, this was the first year that they had heard about it. Stephanie said, I think I have, but I think the younger students couldn't, but I didn't think that younger students could do it. Ah, gotcha. Yeah. So the computing challenge is for any students third grade and up. So if you work with students in that age range, you and your students are welcome to participate, and we're going to show you how tonight. Question for you, what brought you to this PD tonight? Did you have a meeting with me or someone else at the Department of Education? You can say meeting. Did you come to a Code Joy show and that's what taught you about it? Did your admin perhaps let you know about it and say, hey, would you attend this and learn more about it? Or did you hear about it from another source? But how did you hear about this professional development tonight, and how did you hear about it in order to come? I think that's really useful for us to know kind of what communication channels these come through. Stephanie says, my admin let me know about it, and I did a Code Joy lesson. Awesome, great. Jordan says, I was looking for more information about the challenge, and this is also my first year teaching computer science. Excellent, excellent. So I'm looking for all sorts of opportunities to learn more. Great. So it sounds like both your administrators had heard about it and asked you to learn more, and then Stephanie, you also did a Code Joy show. That's great. Excellent. Well, what we want to do now is share something in the chat with you. What we're going to share is a Google Doc, actually. And this Google Doc is going to have all of the information that we're going to cover this evening. So all of the links that we're going to share, all the information that we're going to share, and all the information about the challenge that we're going to go over is on that Google Doc. So if you go to the chat, you can find that and check a little bit more out about that. So I'll just show you what that looks like here. And I see you guys are joining us there. So this kind of has our agenda for the evening. And then if you scroll to the second page, a little bit of information about the state of computer science in the state of Connecticut. And so we're going to go over some of this now, and we're really lucky to have Jennifer Michalek with us from the Connecticut State Department of Education. So I'm just going to share some information that we've found from both the Code.org Connecticut report on computer science education and the EdSite State report. I highly recommend checking both of those out, especially the EdSite State report. You can actually get a really good measure of where your district falls in comparison to other districts. It takes a moment to load here, but once it does, it has this amazing dashboard full of really useful information about computer science in the state of Connecticut. So definitely check that out. But a few tidbits that we pulled from those reports that I'd love to get your thoughts on, Jen. One of them is that in Connecticut, there are currently over 7,000 jobs in computer science that are open, that are unfilled, but only 608 folks graduated in computer science in 2020. So that kind of means like, man, Connecticut is not quite preparing folks for the jobs that are available. Can you add some more Connecticut context to that?
Yeah, we know that this remains an issue. It's why computer science is actually specifically called out in the governor's workforce strategy. We're hearing from many of our computing employers that they have to go to states like New York, New Jersey, and Pennsylvania to fill Connecticut jobs.
Right. Well, it's great that this challenge is here, sort of encouraging that a little bit more. So just communicating the job market need for more computer science education. So that makes us really glad that folks like Jordan have joined the team and you're teaching computer science now. Our second point that we pulled out is that 93% of parents want their child's school to teach computer science. So that means that you as a teacher already have some support in your community to do this. Are you hearing from other parents and community organizations about enthusiasm for computer science, Jen?
Yeah, we're finding it in a lot of different sectors. There's kind of a lot of grassroots efforts around computer science in Connecticut. And so we're really trying to put all those efforts into a really cohesive rollout for computer science to help districts with that implementation.
Awesome. And that's actually a great application of this computing challenge as well. Kids can do it in school with you as their teachers. They can also do this at home with their parents or their families and submit their ideas independently as well. So we can capitalize on some of that community support for computer science. The next one is that Black students are more interested in computer science and more confident in their abilities than white students, but they're less likely to enroll in a class. So that means that whatever our preconceived notions are about who computer science is for, computer science is really an avenue for all students to succeed. Can you maybe speak to the diversity of Connecticut schools, Jen?
Yeah, so Connecticut, despite us being a really small state, we have over 169 districts that are all very, very different. Most recently, our underrepresented populations are actually overrepresented now. They actually bypass the 50% mark.
Yeah.
So that becomes something that's really critical. And there's a lot of research out there to support, that computer science education really advances achievement in other subject areas. Yeah. So while it's not a tested discipline, it has an impact on those achievement levels and growth levels that we are looking for in students.
That's really interesting that Connecticut is now a majority minority state when it comes to student populations. That's awesome. Next one is 94% of Connecticut students have access to computer science, but only 13% of students are actually participating in computer science. So that means that there's not necessarily an access gap to computer science, but there is an engagement gap. So I think an invitation, a question there is, all right, how can we engage all Connecticut students in computer science? It's not just, here's an opportunity, go for it, but how can we actually engage them? What can we do to bring girls, students of color, students with IEPs, students who you may not think might like this? How do we give them the opportunity and then pull them into this? I think there's a lot of great opportunities through this computing challenge. And then finally, in 2018, the teacher preparation programs in Connecticut, did not graduate any new teachers in computer science. Now that was 2018, that's been a few years ago, but I think there's a real opportunity there because that means that you're just as qualified as anybody else to bring this into your classroom because we need you. We need you whether you've been to that program, whether you have the training, whether you're comfortable or not. We need you as a teacher to be bringing this into your classroom. Do you want to speak to the teacher preparation programs in Connecticut a little bit?
Yeah, so in Connecticut, if you are a certified teacher, you can teach computer science at the grade level in which you're certified. And most recently, we have added a cross endorsement. So you can get that cross endorsement by either some coursework or by passing the praxis test. Again, it's a way to make you more marketable if you're looking to expand and maybe teach more CS and kind of go out of your area a little bit.
Excellent. That's great. That's something that code.org did not have in the report because their report is a couple years old. So making huge strides in Connecticut. That's great. So let's get into the Lieutenant Governor's Computing Challenge itself. And maybe, Jen, we'll spotlight you here first, just to maybe give us a little history of the Lieutenant Governor's Computing Challenge, because this is our first year being involved, but you've been around for quite a while with the challenge. So how did it start? Where are we at?
Yeah, so I've been involved with the Computing Challenge since the inception, and while the world was shutting down in 2020, we started. That's how it came to be, was really an opportunity for districts to do something different with their students. And ever since then, we've made improvements and added components to the challenge to make it easier for participation. The second year, we gave a menu of different options, which Kelsey will speak to later on. Last year, we had a recognition event in which 27 different projects were recognized by the Lieutenant Governor. And a couple of those projects actually also had students receiving cash prizes. And this year, we're fortunate enough with our partnership with Infosys Foundation USA to partner with CodeJoy to bring not only this professional development to teachers, but more importantly, some opportunities for students to participate in some of the coding experiences, to have that appetite for coding in their schools.
You know, it's amazing to see how much this challenge itself has grown. And then the support for computer science across the state has grown as well. That's awesome. There was a question that came in from the chat from Jordan asking about that cross certification. Is that specifically for computer science? They said their admin is pushing them to get a tech ed cross cert, but maybe this seems a bit more relevant. Can you add a little bit more context for that?
Sure, they actually have both are available. The tech ed cross cert, you can get by passing the praxis for that. There is also a unique endorsement for computer science. So a lot depends on what it is that your admin is looking for you to teach. But both are possible cross endorsements. I say go for both of them.
Do it. Yeah, absolutely. That's great. Well, thank you so much for adding some context to what this Lieutenant Governor's Computing Challenge is and really how far it's come in the last couple of years. So we're going to dive into what it is and where to find more resources about it in just a moment here. Thank you so much, Jen. As we're going tonight, feel free to pop in with any additional context, any corrections to anything that I'm sharing, and we'll keep an eye on that chat as well. If you guys have other questions, maybe Jen, you can kind of answer some of those in the chat too. Thanks.
Absolutely. Thanks for having me.
Great. So we're going to now visit this website, and the website is ltgovcc.org. I'm going to put this in the chat for everybody if you want to visit it, and we're going to visit it on my screen as well. This is the website for the Lieutenant Governor's Computing Challenge, where you can find all of the resources that we're going to talk about this evening. But just to give you kind of a high-level overview of what the Computing Challenge is, basically, the Computing Challenge is a statewide challenge just for 3rd through 12th graders in the state of Connecticut to engage in computing in whatever method works best for them, for you, for your classroom, etc. There are 3 different levels of this challenge. There's the concept-only challenge, the prototype challenge, and the development challenge. So starting with this concept challenge, in this one, the students just think up an idea for a real problem that's important to them. So anything from, oh, I have a friend who has asthma and I heard that air quality can affect that, to, man, bullying is a big problem in my school. Whatever problems are important to them, or perhaps for you as a teacher, maybe you're a social studies teacher and you're diving into census data and you want to do something more interesting with census data other than just read a table. This concept challenge, all they need to do for this version of the challenge is think of a problem and then think of a computing solution. And that computing solution, we use the word computing in order to keep that really broad. A computing solution could be a website they design, a game that they create, a coded PSA, a public service announcement, could be a robot or some sort of wearable technology, or even an app that they design for a phone. And in this version of the challenge, they don't actually have to make that solution or do any coding. They just have to think of the problem and think of the solution and then kind of write it up. So in this version of the challenge, they describe the problem, they describe their solution, and then they also submit some sort of audio visual component. And that could be like a little video or a little slideshow, something like that. Just has to be less than a minute. So this could take as little as like one class period to have kids participate in that. All they do is submit a Google form for that. Now in the prototype and development challenges, in this one, they actually start to create whatever their solution is. So maybe they, for the prototype challenge, they start to create a website. And maybe they don't have the entire website done, but they have a page of that website that works. Or they have an idea for a game that could raise awareness about bullying or seatbelts or recycling, whatever they're interested in. And maybe they don't create the entire game, but they create a couple levels of it. So they get at least some element of their project working. So in this one, they submit their problem, their potential solution, and a little snippet of code or a screenshot of their code or a link to their code that they actually start to create. It doesn't have to be done. It doesn't have to be perfect, but this is the get a working prototype of at least part of your project. And the development challenge is that they do the whole thing. So they make the website, they create the robot, they make the wearable technology, and it works. And so we're going to see a couple examples of student submissions from the past that would fit each of these different concepts here. So that's kind of an overview of these different parts of the challenge here. And we wanted to highlight that on the website, there are a ton of great challenge support materials. So I'm going to come back to the website here. And the first place I'm going to go is all the way up in the right-hand corner. There's this orange button, which takes you to some of the things that are available that we're offering this year as CodeJoy. So teacher professional development, you can see we're at the second PD here tonight. And then finally, there's one more day left of student sessions. So in these student sessions, the last one we have available here is robot aerobics. We added one final day, which was March 17th, St. Patrick's Day, just because we had that snow day a couple weeks ago. So we want to do a makeup day for that. But during the CodeJoy student sessions, we teach the kids how to code. They don't have to know anything going in, and you as a teacher don't have to know anything going in. But we teach the kids to code, and then their code actually controls our robots live during the broadcast. And so during Robot Aerobics, they're actually controlling some little dancing robots. It's pretty fun. If you want to check it out, just visit that website, and then you can check out and see which times are still available on March 17th. We'd love to have you join us for that final day of CodeJoy shows. So those are some things that are available on there, but there are some other things that we also wanted to point out as well. I'm going to go back up here and go to the resources tab up here. One amazing resource that is available this year is mentors. Now, these could be mentors for your classroom, for you as a teacher in your classroom. This could be somebody who video chats in and gives the kids some ideas and some pointers. These could even be mentors for individual students. So if you've got some students that are really wanting to take this to the next level and submit a really cool idea, they can totally do that. And there are some mentors available to help. There's also some standards alignment, and I'll highly recommend checking out these submission tools. There are some templates and some scoring criteria for each of the different levels, because this is a challenge after all. There are going to be some folks and some student projects that are selected and elevated as the winners. So if you want to help set your students up for success, check out those scoring criteria, the how-to guides, and the documents that'll help you out as well. Also, I want to point out under additional tools, there's also a couple great additional tools down here. I want to highlight this Apple App Design Journal. This is a great printable resource if you want to go through at least the concept challenge of designing an app, and we're going to show you how you can prototype an app later today. But if you want to help your students kind of think through what is an app and how do I do it, there are some great, this is a great like printable journal basically to take the kids from the brainstorming phase to the wireframing phase and beyond. Plus there are, again, a bunch of other additional resources down there that we want to make sure you check out. All right, so we did want to show you a couple examples of past submissions, starting with an idea of what someone submitted as the concept challenge last year. So this student was, I believe, a middle school student, a high school student. This was one student submitting this by themselves, one female student, and she had an idea for an app. Now, she didn't actually make the app. She just explained the app in a little video. So let us play you a little snippet of that right now.
My concept idea is creating an application to promote the development of and continuity of sustainable habits. Climate change and related issues cannot be combated without public support and efforts. Sustainable habits are widely known to reduce the effects of climate change, and through online media, people can create connections that encourage sustainable behaviors. purpose of this application is to motivate users to develop and maintain sustainable habits using the peer pressure of an online community and the positive feedback of a point reward system. How this would work is the application would recommend various sustainable habits to users. Every time a user engages in each habit, they go into the application and input this information. Users will receive points for completing a task, and after users receive a certain amount of points, they can receive a reward. Participants can also engage with each other on the application.
So that's kind of an overview of what that can look like in the concept challenge phase. Doesn't have to be very complicated. She didn't actually start creating the app at all. She just had an idea for an app and submitted a video explaining the problem and her solution, which was pretty great. Now, that particular one was one student by themselves submitting this idea. Students can submit their submissions to the challenge in groups of anywhere from 1 to 5 students, but they do have to be in the same grade band. So they have to all be in 3rd through 5th grade, 6th through 8th grade, or 9th through 12th grade. So you can't have like an 11th grader paired with a 4th grader. They've all got to be in those same grade bands there. So that was a submission for the challenge concept last year. Now we're going to show you one for the prototype challenge. Now this was submitted by 3 students working together. These are in elementary school. These students are in elementary school, and so they have the cutest little voices. They're really great. They created a prototype of an app using Scratch as a programming language, which we're going to look at tonight. So pay close attention, but they're going to talk you through the app that they created together.
The 3 functionalities of our app called Cock-a-doodle-doo. We use Scratch programming to develop this app. This is the login page.
Hello, welcome to your trusty time scheduler, Cock-a-doodle-doo. What screen name or username would you like to use?
So my name is Kushi, so I just typed that in.
How old are you?
I am 9.
Can I have your password?
The set password is 12345. And by the way, never share your password with anyone.
Thank you.
How great is that kid? Never share your password. This is important. That's a whole different PSA. That's great. But as you can see, they started to create a little app. The problem that they were solving was, man, sometimes we sleep too late or we don't know how to fit everything we need to do into a day. And so they were creating a scheduling app for themselves. Awesome. So that was an example of a submission that was submitted to the prototype challenge. And now we're going to look at a full development challenge. Now, this was submitted by a middle schooler, one middle schooler by themselves, and she called her app Mila. Now, her submission was actually pretty interesting because it wasn't just one thing. It was actually a few different things. So rather than just show you a video, we want to show you what the website looked like where she put all of this stuff together. And also you get to see what the submissions look like. So here she's got a video that we're going to show you a little bit of. There's an overview. She kind of talks about the audience, herself as a coder, how the application works. But we're just going to show you a little bit of this video. You'll see that there's actually an app, there's a web development component, and there's a physical computing component, an actual piece of hardware that she designed as well. This is a really phenomenal project. Check this out.
Hi, my name is Suchita Srinivasan, and I'm an 8th grader from Don Moscow, Cheshire. My project this year is called Mila. Mila reduces the impact of domestic violence by sending an SMS to the victim's contact list or the police. These are the hardware components of Mila. Mila consists of an analog sound level meter, an OLED display, a breadboard, and an ESP32 Huzzah microcontroller. There are various technologies used in this project, such as Arduino, Twilio, Firebase, and iOS Swift. I'm now going to run through my program. This is my Arduino code. It consists of 2 main files. The config file contains the variables for configuration, and the main file consists of my logic.
To show you this project in action. Back here.
The alarm, I'm going to scream, ah!
So when she makes
As
a
you
noise,
can see, the decibel value has exceeded 75 decibels, which is the threshold, and I should soon receive a text alert informing me that the alarm has been triggered. As you can see over here, now that I have not disarmed this alarm, I'm going to receive another text alert informing me that a message is being sent to the contact list. Over here. And finally, the message being sent to the contact list should be seen shortly. We just expand that over here.
so as you can see, that particular student man, she went all out on that project. She's got an app, she's got a website, she's got a physical computing solution that she created. And you'll also notice that she was a middle schooler, right? That wasn't a high schooler, that was a middle schooler who had something brilliant. The problem she was trying to solve was the problem of domestic violence. So when a loud noise would trigger this device, it would automatically send a message to the person's contacts. And so if you want to check out more about that project, you can click on the link that we've got in there. There's a video and an app demo right there. So those are 3 submissions from past years, but we know that a lot of teachers, this may be your first time teaching computer science, perhaps your first time engaging in the computing challenge. And so we also wanted to give you a couple of different starting points for, okay, how do I start doing computer science in my classroom? And so last time during the professional development, we went through Microbit as a physical computing tool with an online simulator so that you don't actually have to purchase anything to try to do something with a Microbit. We talked about that Microbit and this curriculum that goes with it called Project Tricks, which is also free. All the resources that we're going to share tonight are completely free because education should be free. We wanted to use things that are free, that are robust and have been used in many, many classrooms so that you're not debugging somebody else's technology. And we wanted to also be very conscious that the tools that we recommend don't advertise to children. So those are some of the qualities that we were looking for in some of these starter projects.
Now we're going to start with kind of jumping off of that student's last example, Mila, where she had both a physical solution and a coding solution. They were all kind of interconnected together. We thought we'd jump off by talking about a little tool called a Microbit. And let me know in the chat, have you guys heard of a Microbit before? You ever seen one of these things? They're kind of cool. It's basically a little palm-sized computer, basically, and it's got a bunch of cool features to it. Yeah, and I see a few people have heard of it, a few people haven't. Cool. But it's basically a little palm-sized computer. It's got different kinds of inputs, so you can like press buttons on it, you can tilt it, etc. It's also got outputs. These are LEDs on the front, and the new version has a buzzer, which is great. But I want to assure you, we're only focusing on solutions that are free. So yes, this is a physical tool. It is something that you can buy. However, there is an online coding platform that has a simulator of this built in. So your students can code a Microbit and see what will happen without actually having a Microbit, because we know not all schools have the resources to buy a whole classroom set of whatever. So we just wanted to show you what coding with a Microbit could look like. We're going to show you one little activity with that. So I'm going to hop back over to our Google Doc here. Now, the activity that we're going to show you with this Microbit is using a coding language called MakeCode. If you've ever done any block-based coding before, MakeCode is going to look very familiar. It looks very much like code.org coding languages. It looks very much like Scratch or Snap. And the project that we're going to show you isn't something we made up. It's from a free curriculum called Project Tricks. So we're going to be doing Project 2 emotion badges, but there are actually 8 different projects in this curriculum. They're all completely standards aligned. This thing is ready for you to just pick up and use in the classroom completely for free without purchasing anything. So just to show you what this looks like, I'm going to go to MakeCode. This is our programming language here, MakeCode. Oh, I'm going to start a new project. Great, new project. I'm going to call it LTGovCC. Great. So this is what MakeCode looks like. Here in the middle, just in case you haven't done any coding before, here in the middle, these are all different folders full of blocks. And as I click on these folders, it opens up and shows me a bunch of different blocks. Great, LED blocks, music blocks, logic blocks. I'm going to zoom in a little bit because I don't know about you guys, but my eyes are failing. Math blocks, great, input blocks, awesome. Over here on the right-hand side, this is where you actually drag those blocks to create a code. And then whatever you code over here on the right side will show up on this simulator on the left side. So sure, I have a Microbit, but let's pretend I don't. I don't need one because I've got this simulator on here. So your kids can actually be doing robotics and physical computing, even if they don't have the tool. So let me show you about this, project about emotion badges. It pretends that there's a little creature named Trix who's worried that they won't understand are facial expressions. And so they want to use the LEDs of the microbit to program different emotions so that we can communicate a little bit more effectively. Now, I bet you can already think about certain students or certain needs that folks might have where they may struggle to recognize facial expressions. We're going to do something like that here. So we're going to make a program in which when we press the A and B buttons of our microbit, there's an A button, there's a B button. When we press the different buttons of our microbit, that it's going to show us different emotions. So when I press the A button, I'm going to draw a happy face. Do, 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 do. And again, this is on the Google Doc for you. If you want to code along with me, just click on that link that says Make Code right here. That'll open Make Code and you can code right along with me. So when I press the A button, it's going to show me a smiley face. But again, I'm going to pretend that I don't have a microbit here. I'm going to use the simulator. So I'm going to go to my simulator and I'm going to press the A button and I get a smiley face. There it is. Okay, now I'm going to, when I press the B button, so I'm going to change this to the B button. Well, now I'm going to create a sad face because sadness, that's an emotion too. There, okay, sad. So now I'll let my simulator reload here. And now I can press the A for happy and the B for sad. Super simple. And if you have a microbit, great. You can download the program and you can work with it physically. But if you don't, you can just use your simulator here. So this is a very, very, very simple activity. There are lots more complicated activities and project tricks, but this is just one that we could show in like 3 minutes. Okay, so important question. Cool. Microbit looks cool. Block-based coding looks cool. But very importantly, how do I turn this into a computing challenge project? Well, if you want to do just the concept or the prototype challenge, you can do that without having the hardware at all. If you want to do the concept challenge, you'd want to have the hardware for that. So this could work for any of those 3 challenges. But basically, you'd take this and you'd turn it into some sort of a guiding question for your students, like, how could we use a microbit to help someone communicate? And just by going through some of the different tools in here, you may find different ways to use a microbit to communicate. How could you use sound? How could you use letters on the microbit? Or another guiding question might be, how can we use technology to help with our emotions? What app could you create? What website or robot or game could you create to help us with our emotions? Big guiding question, and anything that they might think of or create could be submitted as part of the computing challenge. So that's one starting point. There are so many starting points here, but that's one if you're looking for a physical computing solution, even if you don't have the physical tool. Microbit's a great one for that. We also wanted to highlight code.org. Now, we talked about code.org and their impact on nationwide and statewide policy earlier, which is prolific, but they're not just for the bigwigs, they're for us too. They're for us practitioners in the classroom. They have a ton of free, like linear courses, step-by-step courses for elementary, middle, and high school. And they have these great free hour of code activities. So just to show you what those look like, if you're interested in it, this is where you would find those linear courses. I'm going to zoom out just a little bit so we can see it. There we go. So it's kind of aligned to the different grades here. So let's say you're a middle school teacher. The CS Discoveries course would be great. You can click to learn more and you can check out the entire course. You can just access it, which is amazing. And in fact, we know that about 30% of teachers, a little over 30% of teachers in Connecticut are already using code.org. So if you're already using code.org, great, start here, follow along with some of these lessons, and then let that spark some ideas for your students. But there's also these great hour of code activities. Now let us know in the chat, have you done an hour of code activity before, or have you worked with code.org? We'd love to know. Let us know, have you done anything with code.org or an hour of code activity? Looks like a few people have. Great, Christina has, Joanne has. Excellent, that's awesome. These hour of code activities, when I click on this, it's gonna be like a little overwhelming because there are so many. Whatever you're into, whatever your kids are into, are they into Minecraft or the ocean or Star Wars or Space Jam? You know, how kids really like Space Jam still. No, there was a new one, the new Space Jam. Great, and Pam uses code.org curriculum for her middle school students. That's great. That is an awesome endorsement, Pam. But there are just so many different activities here, and they all take about an hour. And what's really cool about them is that you don't have to be the expert on any of this stuff, because these lessons are just set up for you. They're step by step with students, and they lead them through an activity. Now, most of these activities, they align to like Wakanda Forever or, Google or Code Combat or whatever. Code Combat may or may not be a great fit for the Lieutenant Governor's Computing Challenge. I'm not sure what problem that one is solving. But if you get in there a little bit, there are some cool games that could be a great kickoff for this computing challenge. For example, we've highlighted this one called Plastic Pollution PSA, and I'm just going to show you what this looks like. I'm going to click on it and just show you how to get started here. Okay, so for this hour of code activity, we're going to look at the ocean. We all use a lot of plastic and we only recycle a little bit of it. So I'm going to click next to get started. And then it says the first thing I'm going to do here is it's going to kind of, this isn't block-based coding. This one particularly is text-based coding. Now, I want to be clear, code.org has block-based, text-based, all sorts of things. We just picked this one because it seemed like a good fit for the computing challenge. But the first thing it's going to have me do is pick a background, and I've decided I like this video here. Look at that. It's loading this video. This is kind of like in Scratch or a lot of block-based things. This is my simulator up here. This is what's happening in this video that I'm creating. I'm creating a PSA video about plastic in the ocean. Okay, next, great. Now it says, oh, I can add some effects to my video like tint. Oh, so it tinted my video red up there. Do I like red? Do I want red? No, I don't want red. I'm going to change it to, ooh, I got a whole thingy here. Green, yeah, green, that looks toxic and wasteful. Yeah, that's the one I want to do. And then it's doing 50% of this toxic green tint. I want a little less. Yeah, a little 20% green tint. Great. Next, oh, I skipped ahead, sorry. I played with it before. Oh, and now I can add a whole bunch of other effects to it. So now I can add a vignette effect. Okay. Oh, that looks pretty dark. I want a little less vignette, like 20% vignette. Yeah, there we go. So it's updating my output, this video, as I go here. And as we go through, I can now start to add emojis. You turn those emojis into floating pieces of trash, and you learn how to animate them. And then you learn how to add text to this as well. And so this, as you've seen, none of you had to be an expert on this. I just have to be a kid who can read directions. I know that can be a challenge, but as long as I'm a kid who can mostly read directions, I'm bringing myself through this tutorial. Now, this is a step-by-step thing. There's not a ton of, there's definitely some creation elements. I take that back. There's definitely some creation elements, but really it's just kind of getting their feet wet, writing code, manipulating code a little bit, learning, yeah, I can code. I coded a plastics PSA about the ocean, right? Builds up that confidence a little bit, but how do you turn this into something for the computing challenge? Well, if you were doing the concept only challenge, maybe you say, all right, well, what sort of public service announcement game could you create with coding? And they think, I'd like to make a game about bullying or wearing seatbelts or something that's important to them. They don't have to make the game. They just come up with the idea for it. That's the concept only challenge. In the prototype or design challenge, maybe they actually create that PSA game on a topic of their choice using something like Scratch or code.org or whatever coding language you guys are already invested in.
Tonight, we're going to go over Scratch. Now, I don't know if you guys have ever used Scratch before, but it is a program that came out of MIT. And it's a really robust program. It's one of the older block-based coding languages around. And I say older, but that doesn't mean it's like a dinosaur or anything. That just means it's been around the block. It's tried a bunch of different things, and it's being used in hundreds of thousands of classrooms all over the world. So if you don't know about Scratch, let me show you. Let's actually start with a little project that I made just to give you a sense of what Scratch looks like and what it is. And then I'm going to actually show you how I built this project. So I spent about 20 minutes today building this little project here. When I start the project up, this was meant to help people figure out how to reduce, reuse, recycle, right? How do we reduce? So when I click the green flag, play some super chill music. I'll make this full screen here. So I just click on the letters to get some good tips about how to reduce. I walk when I can't to reduce my gas consumption. I only buy the vegetables I need. I don't buy products in non-recyclable packaging. I use fabric towels instead of paper towels. I buy local products to reduce the gas spent in transportation. And I only buy clothes twice a year. This would be a really simple project for students to do in the classroom. It wouldn't take much more than a single class period to do. And this is something that you could submit for either the prototyping or development version of the challenge, creating an interactive PSA, public service announcement for the topic of their choosing. So let me stop this project here and I'll show you how I created it. So if you want to do this right along with me, you certainly can. I'm going to start by going to scratch.mit.edu, and I'll put this in the chat as well. So if you guys want to code along with me, you can. But really, we just want to show you what the first 10 minutes of teaching computer science in your classroom could look like. So check this out. I'm going to head on over to Scratch. There we are. And when I get there, I've already signed in. One thing that you might want to have your students do, especially if they're going to share these projects, which they are because it's the computing challenge and we want to see their code, then you would have them create a username and password. When I used to teach this in my classroom, I would keep track of all their usernames and passwords because kids are sort of terrible at remembering that. But what I'm going to do is I'm going to go and create a project. And when you first create a project, there's actually some tutorials that pop up if this is your first time being on Scratch. I think that's really helpful because when you're looking at this, you might be going, what? So that's totally fine. Because I've been here before, it skipped over those tutorials. But I'll show you how I created my little project. Now I'm going to zoom out a little bit so I can see a little bit more on my screen here. So what you have when you're looking at Scratch is you have this little viewing window over here on the right. And then over here on the left, this is where you build all of your code. So you'll see this little cat in the center of this viewing window over here. That's called a sprite. And so the code that we create will affect that sprite. So for example, if I bring this block out that says move 10 steps, and I'm going to zoom in on my blocks a little bit so you can see them better. There we go. Move 10 steps. When I click on that block, see what the cat did? Boom. It moved 10 steps one direction. That's great. I don't really want a cat for this project. I'm going to recreate that reduce project that I just showed you. So I'm going to get rid of that code by dragging it back over here. And in fact, I'm going to get rid of the sprite. So underneath the viewing window down here, that's where all of your different sprites or characters or objects, that's how you can think of them, will be located. I'm going to create a new sprite, which is the letter R. So to create a new sprite, you can go down here, and if you want to use the ones that are already built into Scratch, just click that little cat icon, and now you can find all sorts of different categories of sprites. I'm interested in letters, so I'm going to type in letter, and hey, there they are. I'll make this one a little different. I'll use these turquoise letters, so you know this is live. Okay, so reduce, where do I find an R? R, there we are. So now I see another sprite that I have, which is an R. Great. I don't really want this cat anymore, so I'm going to click the trash can next to it, get rid of it. Great. Okay. Okay, so there's R, reduce. Okay, now I need an E. So I'm going to go back up in here. I'm going to just start by adding all of the sprites that I'm going to need. E, and then I'm going to add another sprite, D. There we are, lining these up. Here's another one, need a letter. By the way, this is why I didn't pick recycle, because recycle's like so long. But so we're gonna do reduce. Oh wait, I already did D, never mind. Oops, I need a U. Letter, we'll come back in here. We'll grab a U, there we go. Almost there, and then I need a C. And then I need one more E. Great. Okay, so I've got all the sprites I need right here. They're looking pretty good. Yeah, nice. All right. So now I've got these letters on a blank background back here. But let's say I didn't want them on a blank background. I wanted like a cool background. Well, way over here off to the right where it says stage, you can actually choose a new background if you want. So I'm going to go down here where they've got that little landscape picture, click on that and find a cool new background. All right, now in this one, I want to be in a jungle. Yeah, that seems cool. Great, I'm in a jungle. So now in order to create different codes, you associate your codes with either the background, which I'm not going to do, or you associate the codes with your sprites that you've created here. So I'm going to start with the R of reduce. And in this code, I'm going to make it so that when I click on the letter, it pops out that little dialog box that you saw. So when I click, whenever you're thinking of something like when I do this or when I do that or when I do that, that's called an event. So I'm going to go to these yellow blocks called events, and I'm going to grab this one that says when space key pressed, like so. When space key pressed. Actually, that's not the one I want. I want the one that says when the sprite is clicked. There we go. So when this sprite is clicked, when the R is clicked, I want, and I'm going to go to the purple looks blocks and grab this one that says say hello for 2 seconds. Now I don't want it to say hello. I want it to give a tip for how to reduce your consumption. So my tip for reducing your consumption is purchase. I'm going to put this in I language so that I'm not preachy, you know. I purchase LED light bulbs, which last longer. There we go. I purchase LED light bulbs, which last longer, meaning I don't have to buy as many. There we go. So in this code, I can also decide how long I want it to last for. So I think it's going to take me more than 2 seconds to read that. So I'm going to put 5 seconds in there. So now when I click on that R, it pops up with that little dialog box. Something else you'll notice is when you do the thing that runs that code, the code will glow while it's running. So that's how you know it's running there. So, okay, I've got my R giving some very sage advice. Now let's get the E to give some very sage advice. I'm going to go to the E and do that exact same thing. I'm going to build the code for that E. So I'm going to go back to events and grab the when sprite clicked, go to the purple looks blocks and get it to give another bit of reduce advice. Anybody have some reduce advice out there? I buy high quality shoes so that I don't have to always be buying and tossing shoes. So I buy high quality products. There we go. So that I don't have to buy as many of them. And once again, I'm going to make that last for 5 whole seconds. Let's test it. So now when I click on the E, there we go. I've got some great advice from there. Now I'm not going to do the rest of these, but I am going to show you how I started this whole thing and how I played a little bit of music. So I'm going to go back to the R here. And now there's a convention that's true in a lot of different coding languages that is the green flag. The green flag is sort of like the Uber event. A lot of people use that to start off their whole project, and we are too. So in my events, I'm going to get this green flag, and I want 2 things to happen when I click the green flag and start my project. One thing that I want to happen is I want that R to tell me what to do, to teach me how to play, so that when we start the project, it's going to say, click a letter to get advice on how to reduce your carbon footprint. Did I spell everything right? Close enough. How long do I want that to last? Maybe, again, about 5 seconds. So that's one thing I want to happen when I click that green flag. But the other thing I want to happen is I want to play some cool tunes. So I'm going to grab another one of those events because I want something else to happen right at the same time. I want it to say this thing and play some music. And to play some music, I'll go into sounds and grab this very first one that says play sound pop until done. Now, this pop sound, if I just click this, you'll hear it. Sounds like that. Very simple. Great. Not what I want it to be, though. I want to have a different sound. So I'm going to go up here to the sounds tab up here. You'll see there's code and costumes and sounds. You can do all sorts of things with the costumes of your sprites. Change the color, change the look. We're not going to mess with that right now. I'm just going to go into sounds and I'm going to add a sound. And all the way over here on the left at the bottom, you'll see that there are tons of cool sounds that Scratch has built into it. I'm going to go to this category that says loops because this has some great music that is built to loop, like chill hip hop kind of vibes. So I'm going to do, sounds all right. Sounds pretty good. I like this one. I'm going to choose this one. Okay, so it's going to be funky. Great. So now when I go back to my code, instead of playing the sound pop, because I've loaded 2 different sounds in now, there's pop and then there's this funky dance tune. Now when I go back to the code, I can choose dance funky as my sound there. So let's see what this sound sounds like. Ready? Okay, and that's it. It only goes that far because this is meant to loop. So if I want to loop it and play it over and over and over again, I need to go to the orange control blocks, and I just want this song to play forever because I like it so much. So I'm going to get this forever loop and place my sound in there. And so now, again, I only have code written for the R and the E, but let's see what this whole project sounds like. I'm going to bring it full screen here. I'm going to hit the green flag, and I get my cool tunes and my instructions on how to play. Sweet. So now when I click the R, I purchase LED light bulbs, which last longer. And when I click the E, I buy high quality products. There you are. Again, this is a very simplistic project here, but hit the red stop sign. It gives you a good idea of what's capable in Scratch and how easy and quick it is to get started. It really is just super, super simple to get started with Scratch. And I highly recommend that if you go to Scratch, you go and just like click around. Yeah, I don't want to save this one. You guys got the gist. But you can actually then save and share your projects. You can find out how to do that on Scratch. But one of the highlights of Scratch is that it has a huge, enormous user base. In that sense, it's kind of like YouTube or Roblox or something that has a huge user base of kids and students, but it's completely demonetized. So you can go in and actually check out other people's projects. So I'll click on one just to see what it's like. So it loads the project, and you can then play other people's projects. This is a project that somebody made. How great is this? I haven't vetted it, so I'm not going to play it all the way through because I don't know what it does. But there's some weird ones out there. But what's cool about this is, see this block up here? It says see inside. You can go in and look at everything they created in this project. And this can give you great ideas about how to build codes that you're interested in. Or if your students find a project that they like, they could go in and then make this project their own and do what they call remixing it. Remix, and like make it their own thing that is sort of built on the backbone of something that exists. So the ability to look at all sorts of user-generated projects and then go in and remix them is a huge strength of Scratch. Now, how would you turn this into a submission for the computing challenge? Well, for the concept challenge, just think of what sort of public service announcement game could you create with coding. They don't actually have to make it, but maybe just by playing a couple games and looking inside of them in Scratch, that'll give them a good idea. Or if they're ready for it, for the prototype or design challenge, create the game. Maybe they don't finish it all the way, or it's not quite functioning how they want it to be. That would be the prototype challenge. And if they get the whole thing working, that's a great development challenge submission. So Scratch is an awesome, free, well-vetted and well-used resource that does not advertise to your kids. It's a great place to get started with block-based coding if you're curious about it. Matt and I were also thinking that Scratch could be a great way, as those students did, to prototype what an app might look like or what a website might look like. You can really do endless things in Scratch. I highly recommend that you go in there and poke around. So if you have any questions about that, please feel free to pop those in the chat. But that is our third starting point here. Absolutely, yes. Great. And then our fourth starting point that we are going to take a look at is another resource from code.org, which they call the App Lab. And the App Lab allows students to design apps for their smartphones and talk through what those would be. They actually get to create it with code. And so we wanted to give you just a brief introduction of what the code.org App Lab can look like and just show you one little example. So here we go. We are, there's some project ideas for K-5 elementary schools. There's some project ideas for middle school and high school. We're going to do the elementary school version because we just want to spend about 10 minutes on this. But check it out. We're going to do this greeting card one here, and then we're going to think about how we could adjust this to be something that might work for the computing challenge. So if you want to follow along with me, just go to the starting point for code.org App Lab, which takes you here. And then we're going to go to K-5 elementary school students, the greeting card activity. So when you get there, it's going to look like this. So over here on the left-hand side, this is kind of like Scratch. This is your viewing window where you're going to see what the app actually would look like. And then over here on the right, this is the code that you build. Now, one thing I really like about this is it doesn't start you off with a blank screen. it starts you off with a functioning project that then you can go and remix, kind of like in Scratch. So let's see what this app does just by itself. I'm going to go ahead and run the app. It says, whose birthday is it? It's Kelsey's birthday. Okay. And let's see. I'll hit the check mark. How old are you turning? 29. Yeah. And now I'm gonna click this little check mark here. And there you go. It's a very simple little app. It just says, happy birthday, Kelsey. You're turning 29. Great. So this is the simple app. Again, very simple code, very simple app. But how could you change this to be something that might be more relevant for the computing challenge? Well, you have all this code over here, and just to start I think it's easy to just kind of manipulate some of this code. So I'm going to just reset that here, and I'm going to change what some of these blocks are doing. So instead of a cake, I'm going to choose a different sprite. Notice that it uses some of that same language that Scratch does. So instead of a cake, maybe instead now I'm going to create an app that instead of celebrating a birthday, it celebrates how much trash someone has picked up today, and it gives them a little celebration. Sometimes we just need that little pick-me-up to do the right thing, right? So instead of a birthday cake, I'm going to do a ghost. That seems good and spooky to me. So, okay. A little ghost. I think the ghost kind of looks like a trash bag. We could extend the metaphor, but we won't. It's fine. So instead of asking whose birthday is it, maybe it asks, who picked up trash today? Okay. And then instead of how old are you turning, maybe it asks, how many pieces of trash did you pick up? Or how much trash did you pick up? There we go. And then after it goes to this next one, when the age is answered, show the title screen. So it's going to change to a new screen. And instead of happy birthday, maybe it says, good job. Name is what I entered in. Subtitle, instead of you are turning, it says you picked up this much trash. Great. And then it shows that little ghosty there. And now maybe I want it to make a new ghosty in the middle here. So let's see what that does. Now I'm going to run my app again with the changes that I made. So instead of a birthday cake, it's a ghost, which is quite terrifying. Okay, who picked up trash today? Me, Kelsey. I did it. Okay. And how much trash did you pick up today? 36 pieces of trash. Check mark. And now it says, good job, Kelsey. You picked up this much trash, 36. Woohoo. And again, we just changed a couple of things in there, but you could look at this code and actually start to change a bunch more things in there. And you can, oh, look, we can resize that too, so we can see it a little bit bigger. Great. Good job, Kelsey. Thanks. But you can customize this in a few different ways. It gives you some tutorials and things there. But if I go back to that first screen, it kind of takes you along in some different projects and asks you to modify them in different ways. So whether you use this for to actually start to create your own apps, there's ways that you can go in and start with a blank project and start by prototyping, start to create something for the prototype challenge or for the development challenge, or whether you just use this to inspire your students to think about the app that they might create for the concept challenge. This is a great way. Again, it's free, it's robust and used by teachers all over the world. Many teachers in Connecticut are already using code.org, so this just adds on to that. And it doesn't advertise to kids. There's a lot of different app designers out there that have ads all over them. And that just stinks when you're doing that in class. Let's not advertise to kids. This is a great resource for that. So if you have any other questions about this code.org app lab or anything, let us know. And we can try to answer some of those. But with the last few minutes here, let us talk through how to submit an idea for teachers and students. So I'm going to go back to the Lieutenant Governor's computingchallenge.org website and go to participate. So under the challenge, it's kind of got an overview of these different things. Like we said, the concept challenge, the way to participate with that is to actually just submit where it says start your submission. It's just a Google form. So this one is really, really easy to submit when your students have their idea. their problem, their solution, and their visual component. They just go through and answer these questions. And if you want to prepare them for what those questions are going to be, like maybe have them write their answers out in advance, there is an awesome little how-to guide that takes them through exactly what questions are going to be asked on there. So you can kind of prep for that, which is great. So the concept challenge, super easy to submit to that one. It's just a Google form. Now for the prototype and development challenges, there's a little bit more process that goes into that because there's a little bit more for them to do. So I'm going to go to start your submission. Now what I've done is I've already created an account for myself. So I'm going to go ahead and log in, sign in with Google because I'm here. And what I've done as a teacher is I have set up 2 different class periods. Let's say you've got different class periods of students and you want to have a little bit of control over where are they? You want to check in with them and say, oh, group 2, you guys look like you've submitted this much, and group 3 looks like you guys are missing this piece right here. If you want to manage your students, there's a system that's set up for you here through Launchpad, which some of you may already be using in your schools. Now, students and teachers, you don't have to create a classroom, and your students don't have to be part of your classroom, but you can if that works well for your classroom. So for example, my period 1, that's going to be the prototype challenge, folks. And I can have different students. I don't have any, oh, I do. I have one student. His name is Matt Chilbert. He's also my co-founder with CodeJoy, but he's my student and I can check in and see where he is in his work. But I can also look and see the different activities. So it kind of leads them through these different activities. Part 1 is to make a plan. They create an activity, they do a little walkthrough of it, and then they can submit their plan right here. Next, they create their code and they have to show what their code looks like. And so they can submit the file for their code right here. Next is telling a little bit about the coders. So an overview of the project, who the intended audience is for. For example, from our 3 submissions from last year, the intended audience for the first one to participate in some more sustainable habits might be teenagers. And the audience for the second one is really involved elementary schoolers who need scheduling help. And the audience for the third one is people at risk of experiencing domestic violence, right? They talk a little bit about the audience for their submission. And then the coders, this is their little biography. My name's Kelsey and I'm really passionate about blah, 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 etc. So that's where they do a little bit about their submission and about themselves. And then they got to create a little video. So for the concept challenge, their video has to be less than 1 minute. So a lot of students will do like a little slideshow and then record themselves talking over it. Or maybe they want to say, this is my friend Stacy, and Stacy has asthma. And I heard that I did some research and bad air quality affects asthma. So here's the wearable technology and here's Stacy wearing it, or something like that. So for the concept challenge, just has to be 1 minute. The prototype challenge has to be less than 2 minutes. And the development challenge has to be less than 3 minutes. Makes sense, right? This is where they upload that video of their work. And then they also get the chance to create a logo, because that's the best part of having a great idea. It's having a great marketing scheme for it. So they get the opportunity to create a little logo and put that in there as well. And then finally, there's a consent form, because this is a challenge. We want to pick some winners and we want to promote those winners. There is actually going to be an event in June where we invite some of the winners to come to this event in Hartford, I believe, and they're going to get to share and talk about their submissions and win some awards, get clapped for by everybody. Their parents will get to come. It's a really good time, but in order to be qualified for that, they have to do this consent form here. So that's all through when you go to the participate tab up here. When you go down to the different types of the challenge, you'll get put into that system. And again, that system is voluntary for you as a teacher. You can choose to set yourself up as a teacher and have a roster of students and check in with them and everything. Or you can also just have the students submit it on their own. You don't have to manage them like that if you don't want to. So that's kind of an overview of how to do that. There's also some video tutorials of how to manage that system. If you're curious, we have those linked right here. We're just about out of time tonight, but I wanted to open it up to any lingering questions that you guys might have about this computing challenge. The one thing that I didn't say is submissions are due at the end of April 28th, I believe. So make sure that you and your students get everything done by the end of April 28th. And we really hope that you and your students and some of your co-teachers, perhaps other people in your building, participate as well. And let's bring Jen back on, just in case anybody has any questions about the challenge. Jen has been here a long time and is even more qualified than me to answer any of these questions, but let us know in the chat. Any questions that you guys have about the computing challenge? Let us know in the chat. I'm glad, Jordan. I'm glad this was helpful for you. Great. Wonderful. Well, we'll hang out here for a couple more minutes just in case anybody has any questions, but that's all we have for you guys. I'm glad this was helpful for you, Stephanie. Have a great rest of your night. And thank you so much to Jen Michalek for joining tonight. We really appreciate the support of the Department of Education and all of the work that you guys are doing across the state to promote computer science education. We're really happy to be part of the team. So it's great.